Have you ever just, stopped and thought about all the invisible stuff happening around us all the time? I mean, from the Wi-Fi that's probably connecting you to this right now, to the actual sunlight warming your face, our entire world is literally powered by forces we can't even see. So let's dive in and try to make the invisible, well, visible. Right now, we are all being bathed in waves coming from towers just like this one. They're carrying everything from your favorite radio station to the text messages on your phone. But how in the world does that actually work? How does information just fly through the air? That's the big question, right? It's the one we're going to tackle in this explainer. And believe it or not, the answer starts with a concept that's actually super simple. So to really get how your phone gets a signal from that tower, we have to zoom way, way out and start with the simple, familiar idea of a wave. Okay, this is the most important part, so remember this. A wave is not about moving stuff, it's about moving energy. It's basically a disturbance that travels, carrying energy with it from point A to point B. The absolute perfect example is a wave in the ocean. All that energy is moving toward the shore, right? But if you put a little rubber duck on the water, it would just bob up and down in pretty much the same spot. The energy passes right through it, but the water itself doesn't actually travel all the way to the beach. And you know what? All waves, whether they're in the water or zipping through the air, share this basic repeating pattern. We call that high point the crest and the low point the trough. This simple up and down shape is the fundamental building block for everything we're about to talk about. Now, let's talk about the height of the wave. That's called its amplitude, and it's a dead giveaway for how much energy it's carrying. A tiny little ripple in a pond, not much energy. But a giant tsunami wave has a massive amplitude, which means it's packing an incredible amount of power. It's really simple. The taller the wave, the more punch it has. So now that we've got the basics down, let's build on that, because this is where things get really, really cool. It turns out some waves have a kind of superpower that others just don't. Think about a sound wave. For you to hear my voice right now, the sound has to travel through the air. It has to physically push and pull air particles in a big chain reaction all the way from me to you. We call these mechanical waves because they need a physical medium to travel through. And this brings us to the main event, electromagnetic waves. The big difference? Unlike sound, they don't need any matter to travel. They can just cruise right through the total, complete emptiness of space. This is a massive difference, and honestly, it changes everything. This quote just nails it, doesn't it? Sound needs air, so in the vacuum of space, it's totally silent. An astronaut could be shouting and no one would hear. But sunlight, which is an electromagnetic wave, travels 93 million miles through that exact same emptiness to get to us. That's their superpower. So what exactly are they? Well, the name kind of gives it away. Electro and magnetic. These waves are literally made of vibrating electric and magnetic fields. And the cool part is, these two fields create each other as they go, making this self-sustaining wave of pure energy that doesn't need anything to push on. It just goes. Okay, so now that we know what these things are, let's check out the whole family. You're actually already an expert on one of them, but it's just one tiny piece of a much, much bigger puzzle. Get this. Every single color you have ever seen in your entire life, red, green, blue, all of it, is an electromagnetic wave. This little slice of the family is what we call visible light, and it's the only part our eyes ever evolved to be able to see. So that leads to the big question, doesn't it? If all the colors of the rainbow are just a tiny fraction of what's out there, what else are we missing? What are we not seeing? And here it is, the whole shebang, the full electromagnetic spectrum. This is like a whole universe of light that's completely invisible to us. It's this continuous range from these long, low-energy radio waves on one side all the way to these super short, high-energy gamma rays on the other. And that tiny, tiny little sliver in the middle, that's everything we can see. We are basically blind to almost all of it. Okay, let's connect this amazing, invisible spectrum back to our everyday lives and finally solve that mystery we started with. So way down on the long wavelength, low energy end of the spectrum, you've got radio waves. These guys are perfect for carrying information across huge distances. Your car radio, your TV signal, and yep, your Wi-Fi. All of it runs on these invisible workhorses. Now, microwaves and radio waves team up to form the backbone of all our global communication. They beam signals from your phone to a cell tower, which then shoots it up to a satellite and back down to the other side of the planet, all in the blink of an eye. All right, let's jump all the way to the other end of the spectrum.
Way, way up in the high energy zone are X-rays. Their wavelength is so tiny and their energy is so high that they can blast right through soft stuff like skin and muscle, but they get stopped by bone. And that gives us the incredible power to see inside our own bodies. So when you put it all together, you can see how this entire spectrum, this invisible rainbow, is absolutely essential to modern life. We figured out how to use each part for something different, from the infrared that lets you change the channel on your TV, to the ultraviolet from the sun, all the way to gamma rays being used in highly targeted cancer treatments. And really, that's the big takeaway here. These invisible forces aren't some kind of magic. They're a fundamental part of how our universe works. We've just gotten really good at learning their language so we can use their energy to build the world we live in today. Think about it. We went from being blind to almost everything around us, to harnessing this invisible world to power our entire civilization. It really makes you wonder, doesn't it? What other invisible forces are out there, all around us, just waiting for us to find the right way to see them?